Okay, ELE 111, here's your fifth circuit in RC RL series parallel circuits. It's a 4-component circuit. You'll notice again, like I've said in prior slides, I don't have a frequency shown because I'm giving you the X sub L and X sub C's pre-calculated so that you don't have to go through that in these higher level problems. We're going to be talking about who dominates. I don't know until we calculate ZT. But we're going to discover that as we work through this problem. We're going to solve all the voltages and all the currents. We're going to draw voltage and current phasor diagrams. Again, these are not hard unless you don't have the answers. If you've got the answers, it becomes very easy to draw those phasor diagrams. So, in reality, an RLC circuit is more involved. So what you typically find in this chapter is, although there are a few larger problems, a lot of them are smaller with less parts. And I want to refresh in your mind that you can use Ohm's law everywhere, here, 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 here. So you have to act like a detective. If I want the voltage at X sub C2, one way is to find the voltage of this parallel chamber. Another way would be to find the current. V is equal to I X sub C. It's true for all the components in this circuit. If I want the voltage, I need resistance, which is already given to you. See, you have all the impedances. You don't need that. What you need is to go find a current, or you need to go find you need to go find a current. You either need to know what this current is right here, or this current. And if you had any of those currents, you could find the voltages across each of the components. What's interesting here is these two components are in series, which means if I find the total current in the circuit, I've got the current needed to solve both of those at the same time. Wonderful. There is also voltage divider that can be used. And voltage divider has been handy, but only in series circuits. So this is a series parallel circuit. Unless you break it down, this formula and this formula, which is the current divider, don't always work. But current divider works here. You would need to know what IT is for that to happen. Then you could use current divider. And as a summary about impedances, since we keep drawing circuits with boxes and changing the name of the parts to Z1, Z2, Z3, if you write things down and stay organized, you only need one formula for series and one formula, well, actually you need two formulas for parallel circuits. That's the beauty of converting everything to impedance and using nothing but the formulas pretty much on this page. If you use them right, great things happen. If you use them wrong, bad results, of course, will follow you around. Now, what I want you to hone in on is down here in the yellow, where it says there are many ways to attack a series parallel circuit. Okay, we can't spend enough time talking about what it is that we're after, because you have to have a strategy going in. Okay, for example, there are many ways. If I knew the current going into this parallel branch, I could use current divider and split it. Okay, that would be one approach. That would give me the current here, and that would give me the current here, which then allows me to use Ohm's law. and you're done. But what if you don't have that current? What if what you've got instead of the current is that somehow you figured out that the voltage from here to here is whatever, 3 volts peak to peak? Well, if you've got the voltage here, you've got the voltage here. So maybe in your journey in solving these circuits, that's all you get out of this circuit is you found those voltages. Well, those voltages, well, they convert into Ohm's law. And so that'll give you the current of the capacitor, and this will give you the current of the resistor. Now remember, these are all phasors, so you're going to have to use phasor math to do that. But, you know, this is true everywhere in this circuit. It's all phasor math, and it all comes down to the following. You either find the voltage first and then use it to find the current across a component. Or you find the current first and plug it in to Ohm's law for voltage to compute the voltage across a component. And along the way, we've got Kirchhoff's voltage law, and we've got Kirchhoff's current law, and we've got series and parallel circuits that we have to watch. So this is going to parlay into a second circuit because I'm already 5 minutes, 6, 7 minutes into explaining this circuit. So I'm going to make one more video and start from page 2. So I'll see you soon on page 2. You take care.